So the way to start here with the debugging is trying to figure out if you're running a simulation, something goes wrong. One of the first things you may want to ask, or when you're setting up the simulation, you may want to ask, well, what parameters are available that I can use? All of the components, that's sort of the bigger building blocks, are listed in Appendix B of the PyLith manual. And so you'll see things like the problems, time-dependent, boundary conditions, Dirichlet boundary condition, fault cohesive kin for kinematic, materials, Maxwell viscoelastic 3D, the output managers, the readers, and so forth. So that gives you an idea of, one, what the names of all the components are, and then a brief description of what they're doing. Then, of course, there's also properties. Those are sort of the specific, simple, typed parameters that all of the components or facilities have. Most of those should all be listed in the manual. If you find a component that doesn't have its properties fully listed, please send us email so that we can get that in the manual. The examples of these are strings, such as the file names, integer values, floating point values, dimension quantities. We haven't really talked about this, but you've seen in the examples where we can use dimensions. And then also simple properties are simple arrays of strings, integers, or floats. So that gives you an idea of sort of what parameters are available using the manual. But then in a current simulation, you may want to know, well, I think I set the dimension equal to 3, but how do I know that PyLith sees that the dimension is 3? And so that's where we're going to run in, here we are. In example 3D hex 8 step 1, we're going to use this utility called PyLithInfo. PyLithInfo starts up a PyLith simulation, but all it does is configure itself, looking at all the parameters, parsing it, and then it writes the output. And the optional arguments are verbose, and to change the name of the output file, the default is PyLith_parameters.txt. If you use -8, you get the help info, and then you put in all of your .cfg files and so forth that you want to use. You can't use command line arguments because command line arguments are parsed directly by PyLithInfo. So they all have to be in .cfg files. So an example that I'll run right now is PyLithInfo -- verbose step 01.cfg. So let's go over here to 3D hex 8. And so PyLithInfo -- verbose step 01.cfg. So there's no output directly to the screen, but there is this PyLithParameters.txt file. And so you'll see that let's load this up in the oops. So here's the PyLith parameters. You'll notice that there's a number of parameters here that we haven't really talked about. These have all been set to default values. So things like, well, we did talk briefly about the nodes parameter. That's for running on multiple cores on your desktop. Initialize only, that's set to false. If you set it to true, PyLith will stop once it hits starts to do the time stepping. So this is very useful for if you are trying to set up a big long simulation, but you want to just check to make sure that the parameters are set to what you want. You can do initialize only, look at all of sort of the info files that are generated, and ask for debugging information that would go in the info files, and but it won't start doing the time stepping. Then the job, this is for running in parallel. The launcher, that's also for running in parallel. So right now it's just using the mpitch launcher. You can, in the PyLith manual, we talk about how you submit to a batch queue on a cluster. PyLith knows how to interact with the most common queue systems. So instead of having to create a big shell script with all your batch parameters, you can do much of that in a simple .cfg file. It makes it a lot easier. Then there's the mesh generator. So we've been using the mesh.io qubit, but you'll see here that there is a reorder mesh. You can reorder the mesh in a more optimal ordering of the vertices and cells using the reverse Cuthil-McKee algorithm. You can, when you run in parallel, it'll use the partitioner. Right now there's the default partitioner is set to Choco. You can write out the partition information. And then here's how, currently it's going to use the VTK data writer to write out the partition. Here's our reader, mesh.io qubit. You notice here in the verbose, it's saying what the file name is. So mesh /box hexate. It tells you then the description, and it tells you where that parameter came from. So the PyLith app.cfg file, on line 39, I've set what the mesh's file name was. So if you see a parameter and it looks different from what you think you set it to, perhaps you have it set it twice and you've overwritten it in one CFG file and you thought you had it only, and you have it in, say, 2 CFG files and you thought you only had it in one. So you can use the PyLith parameters with the verbose output and go in and find that parameter and see where it was getting, what the value is and where that value came from. Here's our coordinate system information. Here's our refiner for mesh refinement, our PETSI options. Now we get down in sort of the meat of the parameters. Here's our problem. It's set to time dependent. Configurable as time dependent or problem. So this came up yesterday. I've seen problem, I've seen time dependent. Are they interchangeable? Well, this is telling you that, well, when my problem type is set to time dependent, that it is a type of problem. So I can either refer to it as time dependent or refer to it as problem. Here's our boundary conditions. You can see here's our on line 41, we're setting what our boundary conditions are, that it's an array of boundary conditions. Here's our Dirichlet boundary condition on the x-negative face. Here's the boundary condition set, where it's coming from, the label. Here's all the time-dependent portions, so the change in time, the initial value, the rate value, time history. And so you can go through here and you see every single parameter that PyLith has for your current simulation. Obviously, if you change one of the components, that'll change what your parameters are. So you're not going to see what parameters you can be set, it's what parameters are being set or have been set from the .cfg files. Are there any questions on this file and how to read it? Okay. So right now I am in the directory examples 3D hexate. And I ran, this is the, here's the command I ran. Let's make it even a little bigger. So down here at the bottom, PyLith info is part of the binary. And then, so here I am in the examples 3D hexate. And you can run this, you can run PyLith info on any of the examples or any PyLith simulation. Next, I want to cover some additional debugging. So in addition to the PyLithInfo utility, you can also query parameters directly from the command line using --help. When you see a component called something like pylethapp.timedependent.bc z_negative, to get information about that component, what you do is you would run pylith step 01 --timedependent.bc z_help. So strip off the leading Pylith app and just refer to the rest of the component name on the command line and a .help. So let's copy and paste what that guy is. Oops. So I'll move that up a little more on the screen. So here it's saying, well, I came from the command line. I have the time dependent. Oh, I didn't copy all of it. So there was an error message. It told me from the command line, it said unrecognized bc.z. So you can see that it didn't get the underscore there. So I'm going to refresh the screen here. So this is when I asked for help on the time-dependent BC, that's my boundary condition z-neg. It tells me it's a Dirichlet boundary condition. It tells me the properties are BC underscore DOF, database change, database initial, database rate, and then there's sort of the various help parameters that I can call, label, perf logger, time history change, up direction, and then the subcomponents, also known as facilities, database change, database initial. So the properties, it's listing both properties and facilities. And then I can do more information about the settable properties or settable components. So let's do help properties. So now this looks very similar to what we had on the PyLithInfo file, and then it's giving me the name of the property, the description, what the default value is, what the current value is, where the current value came from, and what sort of validator is being used. Here I've specified a built-in Pylith validator. Let's see, is there another one? All of those are sort of built-in validators. Sometimes you'll see like greater than 0, and that means that the validator means that it's looking for a value that's greater than 0. And so you see most of these values are coming from the default, but there are some of these values that are coming from the .cfg file, and you can find exactly which line they're on. So that's help properties for just a simple types. I can do help components. Here's our components for the Dirichlet boundary condition. So we have a very number of four spatial databases to define the time dependence. They're all laid out on the manual. Database change is sort of the temporal change in the value. Database initial is the initial value. That's what we've been using most of the time. Database rate is for the rate of change. So if you want to give a sort of a velocity to the boundary condition. And then if you have a user-specified time history, there's a spatial database for that. So it's not telling you what is available. It's telling you what is currently set. Well, it's telling me what the defaults are. So these are not options. These are the parameters in the current simulation. Some of them have defaults, and some of them are current value. So current value is like a null component. Basically, it's unset. These are subcomponents that are being unset. That is something that I'll address in a couple slides And that's so why right now you have to go to the manual to see what are your options for various components. So that's how you use the command line arguments to query. Yeah, so here we are. That's all done from the terminal. Wouldn't it be really nice if there was a GUI interface that did that for you? During the government shutdown, I spent my time working on the GUI interface. I haven't worked on it since, and I wasn't able to get it finished, but I set things up to start to use just a web browser, JavaScript based. There's JavaScript's come a long way. There's some nice stuff on ways to use it. The nice thing about how we get the parameters is that I can create, I can on the fly ask for all of the parameters and how things actually fit together. And so I can collect what are the parameters, their descriptions, and what are the possible parameters that things can plug into. And so the idea is you'll be able to browse through what parameters you set. You'll be able to see the description of the parameters and choices using drop-down menus for the various components. So you could see for problem, you could pick time-dependent or Green's functions. It'll use the validation to validate the parameters, and then you can export the parameters to a single file. And so that way, you would have a file that's sort of like PyLithInfo, and that it generate a list of all the parameters you used. You would export the list of all the parameters, so you could use, if some would be defaults, you would have a list of all the parameters you used. That way, you'd have sort of a complete record that you could go back to see exactly what you were using. If PyLith 2.0 hadn't taken so long to come together, we probably would have had a GUI by now.